Good evening, sir.
Hello, dear children. Is my voice audible?
Yes, sir.
Okay, that's great. So, yep. So I believe my screen is also visible to you guys. So yesterday
Yes, sir.
we were dealing with identities, expansion, identity factor, all these problems. I'll just
Sir, yesterday we had a class.
sorry, I mean in the last class. Yeah. 41. So we have learned these identities x square plus like x square plus a plus b in the bracket x plus ab, then a plus b the whole square, then a minus b the whole square, then a plus b into a minus b, then a plus b whole cube, a minus b whole cube, then a square plus b, a cube plus b cube, then and a cube minus b cube. We also saw a couple of problems where we are supposed to apply these logics. Okay, in the solved examples we saw a couple of problems amongst the exercises. Okay, fine, I'll do one thing. I'll solve a couple of problems from the exercises as well, and then proceed further towards the worksheet. Okay, or do you want me to solve problems from exercise, or do you want to try them first and then solve the doubts only?
Yes, sir. We can
I,
have one doubt solving session as discussed.
so we will try.
Okay. Okay, you wish to try it out first, right? Okay, fair enough. So you try it out. Obviously, after I complete the worksheet, then only you go for the exercise problems, and wherever as I've already told you, after finishing few chapters, we'll assign one doubt solving session where we'll be solving all the doubts. There, we'll be discussing all the doubts. Okay. Anyway, so worksheet 5, it's identities expansion and identities factor. Going for the first question, if m plus n is equal to 1, then m square plus n square is equal and m square plus n square is equal to 2, then find the value of m cube plus n cube. So you wish to find an identity which relates m cube plus n cube, m square plus n square, m plus n, all these factors. So for starters, I'll just show the identities over here. Maybe everyone can think. I see that Siddharth has raised his hand. I'm pretty sure he's having the answer. Uh, but I will
No, sir.
give to.
Actually, I don't have the answer. To my knowledge, sir, I don't think we have done identities expansion.
Okay, identities, expansion, and identities factor. See, expansion, basically, what is expansion? And okay, just a minute, just a minute. Basically, what is expansion? I'll tell you. See, this is a plus b the whole square. So this is one equation. What is a square plus 2ab plus b square? Basically, you're expanding this equation. You're basically making it longer. Okay.
I think, sir, there are two different chapters.
In your
If
book,
you check
wait,
the
let me
index,
just check.
there are two different chapters.
Just,
So you did chapter 5 in the previous class, but you didn't do the factors.
Wait, in the previous class, we didn't do identity. Okay, okay, okay. We did expansion of X
So we
35.
did expansion, sir. So you taught us expansion. You didn't taught us teach us factor.
Somewhat like that only, sir. They are two different
Mhm.
chapters. That's what I meant to say.
Mhm. I sense your point. I sense your point. चलेगा. No worries, no worries. Okay, so we have done expansions, and we are supposed to do factors, right?
Yes,
ठीक
sir.
ठीक है, fair enough, fair enough. Both works hand in hand. It's like not a big deal. Okay. Since we have done expansion, we'll do one thing. We'll do factors as well. And then we'll move towards the worksheet. Okay. Now, this time, let's start with identities factors. So, factorization means what? Factorization means to find two or more expression whose product is equal to the given expression. So, we have to find two or more expressions. Okay. So let's understand what is that. So remember, we remember these following identities for factorizations. So the first identity we know very well, x plus a into x plus b. We are very well aware what is that. It is x square plus a plus b, x plus ab. And then a plus b the whole square we know, a minus b the whole square we know, a plus b into a minus b we know, a plus b the whole cube, a minus b the whole cube. Here there was supposed to be a cube, it's a printing error, there is no cube. And a plus b into a square minus ab plus b square. What is that? Basically a cube plus b cube it is. Then we have a cube minus b cube. So let us understand how are we going to factorize using these identities. So the first question goes like this. First solved example goes like this. Factorize 4x square plus 6x. Now how to factorize them? Uh, this is the very simple problem. Factorizing means what? Okay, factorizing means what? Finding out two or more expressions who, when multiplied, will give you my original expression. In short, जो भी original expression है, we have to break it into two different expressions in terms of multiplication. For example, in this case, taking common out. So taking common out is a very simplest example to factorize any equation, any identity. In this case, when I take 2x common outside, you have two expressions now. So 2x is one expression and 2x plus 3 is another expression. So when we multiply 2x and 2x plus 3, that time we get 4x, like the original expression, which is nothing but 4x square plus 6x. I believe the first factorization is clear for everyone. First expression, second expression. Okay. So when you multiply them, you will get the original one. Now, second one is like 3x square minus 6x square y plus 3x square. Now, what to do over here? Here, we'll have to take 3x square as common. So when you take 3x square as common, so this is your first expression. Multiply the second remaining expression is x minus 2y plus 1. So basically what you're doing, you are basically dividing or splitting the original expression into two different expressions.
Sir, I have a doubt.
Yep.
Sir, in the question it is given factorize 3x square minus 6x square y plus 3x square, right?
Yep.
But sir, if you check below, it is given 3x cube minus 6x square y.
Oh yeah. It's a printing error. There should have been cube.
So which one? Oh, okay, okay, sir.
Yeah. So going forward, factorize a square b plus ab plus a plus 1. Now, our first attempt is always to take, up until now, here and here, what we tried to find the common factor from all the numbers, and from all the terms. So 4x square and 6 square, यहाँ से भी 2x and यहाँ से भी 2x. So from both places, from all the terms, we were trying to find the same expression to take common out. So that's what we were trying till now. But in this case, you can see you will not be able to find one common factor out of all the terms. Okay. Here you can, like, from the first three terms, you can take A out. From the first two terms, you can take AB out. But from the first four terms, you can take only one outside, nothing else. Well, basically, nothing you can take out. So here we cannot take one common factor out of all the terms. So in such cases, what to do? By grouping the terms, taking out common factors we get. So this time what we have to do is we have to group them now. So let's divide it into group and try to find common factors amongst them. Like in this case, when I take AB outside from first two terms, here I'll be left with a, and here I'll be left with 1. That is a plus 1. And from the second term, if I'll take only one common outside, I'll be left with a plus 1. So here I took ab, I got a plus 1. Here I took 1, here I got a plus 1. So what happened over here? The first term is also giving you a plus 1. The second one is also giving you a plus 1. Now these two groups, from these two groups, I can take a plus 1 common outside. That will give me ab plus 1. So now this is the result of factorization, where these two expressions can be multiplied to give me the original expression. So whenever you feel that you are not able to find one common factor from all the terms, in that case what you're supposed to do, you're supposed to divide it into groups and try to take factors such that you will have some common factors amongst them. Okay. For the fourth problem, factorize x. Yes, Sanjeev, let me know what's your doubt.
Sir, can you repeat the third sum again, sir?
Sure, I'll do that. So in the third sum, as you can see, from all four factors, I can take nothing common outside from all four factors. So whenever you are stuck in such kind of problems, what you have to do is grouping. So you divide it into groups. You divide it into groups and then you take common, such that whatever you are left with, for example, in this case, a square plus a square b plus ab may say, when I took ab common, what I was left with is a from here and one from here. That is a plus 1 over here. And from the other one, when I take one common, I'm left with a plus 1. So what I got over here, I got a plus 1 over here as well, a plus 1 over here as well. So both the groups are having one common factor now. So now I can take this a plus 1 common outside, then I'll be left with ab with the first one and one with the second one. So that gave me a combined result with two expressions, a plus 1 being the first expression, ab plus 1 being the second expression. So this is the result of my factorization. So in short, whenever you feel that you are not able to take a common factor from all the terms, not a problem. You divide it into two parts and then try to take common factors from both the parts, like same common factors from both the parts. Okay.
Okay, sir. Thank you.
Hmm. Fourth question. Hmm. Let's try to factorize this number, like x square plus 8x plus 15. So again, it's the same story. You cannot take a single number or single expression common from all the factors. In this case, whenever you see such kind of equations, they have a name. Do you remember what that name is?
So
Quadratic
quadratic
equation.
equation.
Yes, very good, very good. The name is quadratic equation. The name quadra came from this too. Okay. So this anything square, that the square term, from there we got the name quadra. Okay, hence it is called as quadratic equation. Anyway, so this is a quadratic equation which is having something raised to 2, something raised to 1, and something raised to 0, which means there is x raised to 0 also. Constant means it is multiplied by x raised to 0, because anything raised to 0 is 1. Okay. So anyway, whenever you see a quadratic equation and they want you to factorize, so there is a very common procedure. Are you aware of the procedure of factorizing quadratic equation?
Yes, sir.
Yes.
Okay, that's great. So for if there is any student who is not aware of the procedure, I'll just explain the procedure once for you guys. So see, there are three terms. The first term is with the x square. X square के साथ जो भी constant रहेगा. Constant means any number multiplied with x square. So in this case, nothing is multiplied with x square. So we assume it is 1. So here we assume it is 1. Okay. The first, we generally name the first place as A. A is the coefficient. We call it as coefficient. A is any number which is multiplied with x square. And the second number is generally named as B. B is any number which is multiplied with x. And the third number, which is the constant number, we generally name it as C. C is any number which is multiplied with nothing, basically. Okay, it's a constant. So in this case, A, B, C. So generally, B. Wait, yeah. So you should find, generally you will have to find, a pair of a set of numbers which are related to both B as well as C. The set of numbers, let me call the set of numbers as, let's say, x1 and x2, for example. So these set of numbers must always be C should be equal to x1 multiplied by x2 and B should be equal to x1 plus x2. This should be the relation. Okay. Actually, there is one more catch. I'll tell you what is that catch. Okay. But this should be the basic relation. Okay. When A is equal to 1. Right now, I'm dealing with only the cases where A is equal to 1. A is equal to 1 के case के लिए B should be equal to x1 plus x2 and C should be equal to x1 multiplied by x2. So you have to find x1, x2 such that B and C equations are satisfied. In this case, C is 15 and B is 8. So find two numbers which when multiplied we should get 15, which when added we should get 8. For example, in this case, it's 5 and 3. So 5 and 3 when we are multiplying, we get 15. 5 and 3 when we are adding, we are getting 8. So this equation is satisfied. So my x1 and x2 are 5 and 3. Okay. So I'm just naming it as randomly naming it as x1 and x2. Okay. So in this case, so I'll do one thing. Since I know that the middle number can be splitted into 5, like 8 is equal to 5 plus 3. So instead of writing 8x, what I'll do, I'll write 5x and then 3x I'll write. And now I have 4 terms, 1, 2, 3, 4. Previously, I had only 3 terms. Grouping was not easy with 3 terms. Now grouping is easy with 4 terms. Now, since I have 4 terms, what I'll do, I'll break it into 2 parts. As you can see, they have underlined. This is the first group, this is the second group. In the first group, what can I take common as? I can see that I can take only x as common. No problem. Take x as common. You'll be left with x plus 5. In the second group, see what you can take common as. You can see that you can take 3 common as. So when you take 3 out as common, you're left with again x plus 5. Now, fortunately, what you observe is here also you have x plus 5. Here also you have x plus 5. You take x plus 5 as common outside. What you're left with is x and then plus 3. Hence, you write x plus 3 over here. So these are the two. These these are the two factors of this particular equation. Hence, you can say that yes, you have factorized x square plus 8x plus 15 into x plus 5 multiplied by x plus 3. This is one formula. Okay, I'm just waiting for a moment so that everyone is clear about it. Okay, so I assume there is no doubt. Now, the second technique is we already know there is a formula which is connected to this, which is nothing but x square plus in the bracket a plus bx plus ab. So again, it's the same story. What they have done is like middle number को basically what did I say? The middle number should be addition of two numbers. The last number like x के साथ जो number है that should be addition of the two new numbers and the last number should be the multiplication of two new numbers. So here also is the same thing. Instead of 8, it should be a plus b, which means addition. And instead of 15, it should be a multiplied by b, which is multiplication. So you have to split these numbers such that the addition must be equal to 8 and the multiplication must be equal to 15. So again, it's the same story. So instead of instead of writing a plus b, you will say, okay, fine, a in this case, a is equal to 5 and b is equal to 3. So then you simply convert it into this particular formula. You can directly write it as x plus, instead of a, you'll write 5 and instead of b, you'll write 3. So hence your equation becomes, hence your, hence your expression becomes x plus 5 multiplied by x plus 3. Is it clear?